Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to solve radical equations. Before we actually get into the solving, let's look at a few steps we can follow to solve different types of radical equations. So step one, you want to isolate the radical on one side of the equation. In step two, you're going to raise each side of the equation to the power of the index. Step three, you will solve the remaining equation. And step four, you will check for extraneous solutions. So in problem A, it's asking us to solve the cube root of 7x minus 1 plus 11 equals 7. So if step one is to isolate the radical, that means we want to subtract 11 from each side. So if we do that, we would get cube root of 7x minus 1 is equal to negative 4. Now, it's important to note in this problem that our index is 3. So if we want to remove the radical, we need to raise both sides to the third power. So I'll raise this side to the third power, and I'll raise this side to the third power. So the cube root and the third power cancel each other out, and we're left with 7x minus 1 on the left side. And then we have negative 4 cubed. Now, if you need to, you can put that into your calculator here. So negative 4, I always put negatives in parentheses, to the third power. That would give me negative 64. Now, our third step is to solve the remaining equation. So our remaining equation is 7x minus 1 equals negative 64. So I'll add 1 to both sides, which would give me 7x equals negative 63. And then I'll divide both sides by 7. So negative 63 divided by 7 is negative 9. Now, before you box that in, you need to check that this is not an extraneous solution, because when we're working with radicals, we sometimes get a solution that does not check into our original equation. Now, to check it, I'm using Desmos, but if you're using, say, a TI calculator, you could do this the same way. To get to cube root, I have to go to function here. I go all the way down to the bottom, and I find this nth root, and we're going to put the proper index. So our index is 3, and then under the index, I'll put 7 times. Now for x, we got it to be negative 9, and then we have minus 1, and then side arrow over, plus 11. And in our original problem, all of that was equal to 7. And sure enough, when we put that in our calculator, we got 7. So this solution is not extraneous. It is an actual solution. So I'm going to box it in to indicate that it is my final answer. All right, in problem B, we have the fourth root of 8x plus 12 minus 9 is equal to negative 11. So I'll start out by isolating the radical. So we get the fourth root of 8x plus 12, and that is equal to negative 2. Now, what I want you to notice in this problem is that in this problem, our index is 4. That's very important because that tells us what power we're going to raise both sides to. So in our next step, I'll raise both sides to the fourth power. So the fourth root and the fourth power cancel each other out, and I'm left with 8x plus 12. And over here, I'm using parentheses because it's a negative, negative 2 to the fourth power, which gives me positive 16. Then subtract the 12 from both sides, so 8x equals 4, and then divide. And 4 divided by 8 gives me 1/2, or 0.5. Okay, now we're going to check for extraneous solutions. So I'm going to edit this original problem we did here. I'm just going to change that cube root to a fourth root, and I'll put 8, and then I want to multiply it by, now we got an answer of 1/2, I'll just put in 0.5, 8 times 0.5 plus 12, and then we want minus 9, and we were supposed to get negative 11. Unfortunately, we got negative 7. So what that tells us is this is an extraneous solution. X equals 1/2 is not the answer, and our final answer would be no solution. Okay, now let me show you graphically what is going on here. So I'm going to graph this for you. Let's say we had, let me do fourth root of 8x plus 12, side arrow, minus 9. And I wanted to know when will that equal negative 11. So y equals negative 11. So you can see, let me change that to red so you can see it better. So you can see we have this purple function, square root or fourth root function, and then we have a linear function, y equals negative 11. And you can see, I can zoom way out, they're never going to intersect, which means if they don't intersect, there cannot be a solution. All right. Problem C, we have the square root of 6v minus 38 is equal to v minus 5. Now, in this problem, the radical is already isolated, so we can skip straight to step 2. Now, it's important to note that when you cannot see the index, it's an understood index of 2. So I'm going to square both sides here. All right, so when we do that, that leaves us 6v minus 38. And if I square v minus 5 quantity squared, I get v squared minus 10v plus 25. Now, this is the first problem where we've had a quadratic equation to solve. In all the other equations, we had a linear equations to solve. So for a quadratic equation, I usually try to solve them by factoring, but you could also use quadratic formula. But for either method, you need to make one side equal to 0. So I'm going to subtract 6v from both sides and add 38 to both sides. So when I do that, that's going to give me 0 equals v squared minus 16v plus 63. Now I'll factor this expression, and when I do, I'm going to use v times v for v squared. For 63, I'll use 9 times 7, and I'll make them both negative because we're trying to add up to the negative 16. All right, so what this tells me is I'm going to have two solutions here, v equals 9 and v equals 7. Now, I need to check these solutions because they may be extraneous. So let's see here. I want square root of 6 times 9. We'll check the first solution. Minus 38. And then on the other side, we have, instead of v minus 5, I'll put in 9 minus 5. And they both equal to 4. Now I'm going to change that 9 to a 7 and change this 9 to a 7. And we get 2 and 2. So both of these check out and are solutions to the equation. All right, problem D. Negative 2 plus the square root of 2r plus 3 equals r. So I want to isolate the radical, so we'll add 2 to both sides. So that gives us square root of 2r plus 3 is equal to r plus 2. Now pause the video and try this problem on your own. All right, welcome back. Let's see how you did. All right, hopefully you raised both sides to the 2 power, and that would give you 2r plus 3 on the left side, and on the right side it would give you r squared plus 4r plus 4, and then hopefully you made both sides equal to 0, so subtract 2r, subtract 3, so it gives me 0 equals r squared plus 2r plus 1, and then I will solve this by factoring. So I'll use r and r for r squared, 1 times 1, make them both positive. So here, since both the factors were the same, we get r equals -1. Now again, I'm going to check this solution. So I'll put it back into my original equation, which was -2 plus square root 2, and instead of r, I will put -1 plus 3. And I want to know, does that equal r? So -1 and r equals -1. So that means this is a solution. Pause the video now if you need to fix anything that you might have gotten wrong on that particular problem. All right, problem E. We have cube root of x minus 4 divided by 2 is equal to 1. Now, when we have a problem with a fraction, we want to always clear that fraction first. So I'm going to multiply this side by 2 and multiply this side by 2. Okay, so that would give me cube root of x minus 4. And on this side, 1 times 2 is 2. All right, now we have our cube root isolated. So we can raise both sides to the 3 power. So this would give me x minus 4. 2 raised to the 3rd power is 8. And then add 4 to both sides. So 8 plus 4 gives me 12. All right, to check this one, I want to push the fraction bar. And then we have cube root. So I need to press function, go all the way down to the bottom. Cube root. Here, x minus 4, this would be 12 minus 4. On the bottom, we have a 2. And it should equal 1, and it does, so that means 12 is a solution. All right, problem F. We have the square root of 7x minus 1 is equal to 2 times the square root of 5. So I want to raise both sides to the 2 power. Raise both sides to the 2 power. So that would leave me 7x minus 1 on this side. Here, I recommend you using a calculator for this. Use parentheses, 2 square root 5, side arrow, close parentheses, squared. So that would equal 2 square root 5 to the 2 power is equal to 20. Then add 1, so 7x gives you 21, and divide by 7, which gives you 3. So now we'll check for extraneous solutions. We have the square root of 7 times 3 minus 1. And here 2 square root 5, 4.4721. And notice they're the same on both sides of the equations. So this is a good solution for us. Now, another way we can solve radical equations is graphically. So let's look at the steps to solve graphically. Step 1, graph the left side of the equation as function 1 on your calculator. Step 2, graph the right side of the equation as function 2. Step 3, identify the points of intersection. And step 4, the x value of the intersection will represent your solution or solutions. So in problem A, we have cube root of x minus 1 plus 4 is equal to 5. So function 1 would be y equals cube root of x minus 1 plus 4. The right side will be function 2. So y equals 5. All right. Now, you can graph these on your calculator, or you can graph them by hand. I'm going to graph it by hand just to show you that you can, just to basically to emphasize how transformations can help you graph these functions, okay? So we have cube root of x minus 1 plus 4. So this is the cube root parent function that's been shifted right 1 and up 4. So right 1, 1, 2, 3, 4. This means this is our turning point. This is like our new 0, 0. And the cube root function has a point at 1, 1. So I'll go over 1, up 1. And it has a point at 8, comma 2. So from this center point, I'll go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So it's going this way. And then we go the opposite way. So down 1 over 1. And then left 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. All right. Now we can also use our calculator to graph it. So you'd press function, go all the way down to the bottom, cube root. Here we have x minus 1, side arrow, plus 4. So it looks something like that. Although I think I want to zoom out a little bit so it looks more like our grid that we have on our paper. Okay, maybe even make it, there we go. All right, now our next function is y equals 5. That's just a horizontal line at 5. So 1, 2, 3, 4, 5. Here's what it would look like if you draw it by hand. Here's what it would look like on your calculator. Y equals 5. All right. And the next thing you're going to do is get your intersection point. So you can see, let me grab a different color. I'll use purple. You can see they're intersecting at this point right here. And on your calculator, you can just tap on it. Okay, so it's intersecting at the point 2, comma 5. So the solution to this equation will be x equals 2. X equals 2. All right, problem B. Again, I'm going to graph this two ways. I'll graph it by hand, and then I'll show you how to do it on the calculator. So our first function would be y is equal to x plus 5. And I'll graph that. So I have a y-intercept at 5. 1, 2, 3, 4, 5. And I have a slope of 1. So up 1 over 1, up 1 over 1. I can go the opposite way, down 1, left 1, down 1, left 1. I can keep that going. So it should look something like that. Y equals x plus 5. Our second function is y equals the square root of x plus 7. Which is just the square root parent function that's been shifted to the left, 7. So let me grab a different color here. I'll grab blue. So I want to go left 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now the square root parent function has points at 0, 0, 1, 1, and 4, 2. So let me plot those. So from this shifted point, I go up 1 over 1. There's my first point. And then 1, 2, 1, 2, 3, 4, 1, 2. So it looks something like that. Okay. Now let's graph it on the calculator and show you what it looks like. We have x plus 5. I need to move it down a little bit so we can see this. And then our second function is square root x plus 7. All right, and you can see if you tap on it on Desmos, you can see that the intersection point is -3, +2. So this equation has one solution at x equals -3. All right, example 3. For a given total weight, the speed of a car at the end of a drag race is a function of the car's horsepower. For a car with a total weight of 3,500 pounds, the speed in miles per hour can be modeled by the equation S equals 14.8 times the cube root of P minus 1, where P is the power in horsepower. Use the model to determine the horsepower of a 3,500-pound car with a speed of 92.2 miles per hour at the end of a drag race. Round your answer, round to the nearest whole number. So I'm going to take this information that they gave us. They told us the speed in miles per hour at the end of a drag race, and I'm going to plug that number into this function. So 92.2 equals 14.8 times the cube root of p minus 1. All right, so this is just a radical equation that we're going to solve. We're going to get the radical by itself. So starting out, we'll add 1 to both sides. So that will give us 93.2 equals 14.8 times the cube root of p. Now divide both sides by 14.8. And that will give us, let's see, 93.2 divided by 14.8. I'll round this to 6.297 equals cube root of p. All right, now we have our radical isolated, so I'll just raise both sides to the 3 power. Raise both sides to the 3 power. So 6.297 to the 3 power gives us 249.68. And they said to round it to the nearest whole number. So I'm going to say the horsepower in this problem is 250 horsepower. Now, I also want to show you how this type of equation can be solved pretty easily by graphing. You can put in your one side, 14.8, function, go down here to cube root. We'll use an x instead of p, side arrow, minus 1. Let me make sure I have that typed in right, yes. And then here, y equals whatever was on the other side, 92.2. Okay. And then we want to find out where they're going to intersect. So I'm kind of having to scroll out here a little bit. Now we can see that they intersect about right here. So I'll push that button. And we got, if we round that number to the nearest whole number, we would also get 250 horsepower. And that concludes today's lesson, solving radical equations.